Well, good evening, it's Charlie ZL2CTM. Well, I just want to do a video tonight providing a bit of an update, I guess. Firstly, thanks very much again for those who sent in some feedback on sort of the ideas for this power / SWR meter. What I have decided to do, I definitely do need to have a power meter in the shack. At the moment I'm just relying on this MFJ meter tuner or antenna tuner and the forward power there on the SWR meter to sort of get a gauge of and a bit of a feel for my transmit power. So I think I might sort of go away from that and have a proper power meter. But in terms of the ideas that came up, and what I sort of decided to do, right or wrong, is I'm going to try and make this simple and relatively low cost. And what I mean by low cost is, these meters are quite expensive to buy. I'm quite lucky that these are two old VU meters that came out of an old stereo that I pulled apart many years ago that have been sitting in my junk box. But I fully acknowledge, and it came out in some of the comments, that not everybody has these sorts of displays readily at hand. If I was to go out and buy these right now, a voltmeter would cost in the region of $15 each here in New Zealand, which really just makes it pretty expensive. So what I'm going to do, I'm going to make a power / watt meter that is going to use an Arduino, and then I want to have two display options that I'll put in the code. One if we were driving a simple 16x2, which is easily up spec to 20x4, nice and easy little LCD display with the old I2C backpack on there. And the other one is going to be an LCD screen here. I think this is a 240x340 if I recall. And what I'm going to do on this display is I'm going to have pseudo split meters. So similar to the old MFJ here, we got 2 meters. That's what I want to endeavour to do on this. Have 2 needles, one for forward power and one for reflected, and then somehow displaying power. But all I want to do okay, full stop. That's the plan. Obviously with the LCD display, all I can display is numbers. So it'll just be a numerical number of some sort. But that's the plan. I'm not going to have meters. The other thing I want to do, came out a couple of times in comments, is, and New Zealand's really no exception, getting hands on toroids, or the toroids I should say, is quite difficult. I'm quite lucky that I managed to travel to the United States reasonably often, and I get mine sent to the hotel while I'm there. But I'm conscious that's not necessarily the case. In fact, it's not the case in a lot of other places. So I'm going to try for a start to make a sensor, certainly for the SWR side of the house, that doesn't use toroids. Now, if you look on the internet, there's lots of examples of sort of what I'm doing here, and the other option is to have toroids. One on the main line sensing the current, and then another one sitting off the side with a pick-off for the voltage. So like I say, for a start, I'm going to just try doing a non-toroidal pickup, see how it goes. If it turns out to be an absolute disaster, then I can revisit that decision. But that's, in terms of a design goal, that's what I'm going to do. It's going to be, I'm going to try and get down to 100 milliwatts, so 100 milliwatts through to 10 watts. That may be in a couple of ranges. We'll have to see what happens there. But in terms of moving forward and just playing around and experimenting, I'm going to break this into a series of videos, just sort of stepping stones moving through. Step one, all I want to do for step one is just look at the detector, so to speak, so how to detect the forward and reflected waves, and get a DC voltage. And then once I've got the DC voltage, then I can then condition that in some way, ready for feeding into the Arduino, and then once it's in the software, it's ones and zeros, and it'll become a software engineering project from that point. So what I want to cover today is where I've got to so far, what I've learnt, and like I say, it's just a bit of an update. So what you're seeing there on paper is this. So there are, okay, what I was trying to emulate here, and this, I've had this lying around for quite some time. I decided to sort of dig it back out again and have a good play with it. you'll see on the internet lots of examples of SWR power meters that have a central conductor that's carrying the RF, and then two parallel conductors that are sensing the forward and reflected power that's then being rectified by a couple of diodes filtered to provide the DC. What I decided to try and do is, rather than create that central conductor and two parallel conductors, I thought, why not give it a go and see if I can do that using a couple of pieces of 50 ohm coax there, and have the outer shield that's not actually connected to the earth acting as that parallel conductor. So that's exactly what you see here. You've got coming in, RF coming in, it's being split into those two pieces of coax. Those two pieces of coax are 14 centimeters long. Why 14? Yeah, it's just sort of about the right size for a piece of copper I had. And I knew I had to get it reasonably long to get a reasonable amount of pickup to be rectified. So like I say, it comes in, gets split between those two pieces of coax, gets combined and goes out the other side. The sheath, that outer conductor there, for the top one, notionally the top one, the left hand end goes to a 500 ohm trim pot to earth, and then the other end goes through, in this particular case, a 4148. Yeah, I acknowledge probably a 1N34 would have been a better option, but again, in the interest of keeping this simple, I'm going to use a 4148 and then a 10 nanofarad capacitor, a 103. For the power coming back in the other direction, it's just that essentially reversed, but rather than having a 50 ohm, say again a 500 ohm trim pot, it's a 51 ohm resistor. So on this bottom one here, 51 ohm resistor, which you can see there, and at the left hand end, it's our 4148 and our 10 nanofarad capacitor. So that is the configuration there. Right. Okay, I've got a few things here. I don't have too many notes, but what I did do to calibrate this is I fed in 5 watts. In fact, I actually cranked it up to 10 watts coming into a resistive dummy load. I then set, in this particular case here, I can set the scale to full scale deflection with the potentiometer here, which just drops the current, or puts a resistor in series with that current coming out of that detector diode through to the meter. Set that for full scale deflection, and then adjust that 500 ohm resistor to null the reflected voltage. And once I've done that once, it's calibrated. I've reconfigured the setup to be, because I'm now going to do some voltage tests which we'll look at, to be out of the test transmitter, which is set to CW, is RF. That RF is going through a switched attenuator. It's going into the directional coupler here, so I'm coupling power either in one direction or the other, so it's directional coupling that power. Coming out of that, it's then going into the antenna tuner, and at the moment I've got the antenna tuner set to dummy load. So that RF is now just being dumped straight into a 50 ohm dummy load. Now the reason why I've placed it between the antenna tuner and the transmitter is then any SWR that's on that line I'll be able to see there, because this pickup here now is on the same side as this meter than the lumped elements, the inductors and the capacitors. So at the moment the inductors and capacitors are at the end closest to the dummy load, then it goes to the split needle meter there displaying SWR, and then through mine. So theoretically, if all things being equal, whatever I see there, I should see a similar arrangement here on these two meters. So let's just demonstrate that first, and then we'll go and look at some of the numbers that came off and where I might want to go to next. So just make sure that's turned on there. That's just a switch. I was just isolating the output of this particular diode rather than going through the meter. I just had an open circuit so I could measure that on the meter. Let me just change that again. So it turns the power off. Right, so what I'm going to do here, I'm going to put this around to dummy load through the antenna selector, which will allow me then to tune the capacitor and unbalance the tuner. So I should be able to see then some reflected power coming through, which will be reflected on this display over here. So we just key up now, and we are putting out there roughly a good 5 watts there. And in this particular configuration, which will not be in the final product, this is just what I had lying around, it allows me then to set the full scale. Now notice we've got the old full scale here. If I now tune off the antenna tuner and I start to induce some standing wave, so we're now starting to get some reflected power dancing here, and we can see over there in our reflected coupler that needle there is moving in sympathy with this one. And if I was to drop the power down there, then we'd see this needle here also drop in sympathy with our forward power. So we can see there, we can tell that indeed our directional coupler is sensing the two different waves, the forward wave and the reflected wave, and we are getting, well, we'll see in a sec, that's being rectified and we're being measured. Right, let me just unkey that. So what I decided to do next is I placed this forward power in open circuit. In other words, I disconnected the meter and I put in its place a voltmeter. What I then did is make sure I don't forget to talk about that. I then went through and tried a number of different power settings and frequency settings. So I tried 3 different watt settings or power settings going into this, 100 milliwatts, 1 watt and 10 watts. And I did that by just scoping the output and then making sure I had the correct level of peak-to-peak voltage to give me the equivalent of those powers. And then I tried it within the capabilities of my radio here, across as much as I could of the HF band. Well, this one's not a general coverage transmitter, so 80 meter band, 40, 14 and 21 meters. So 3.7 megs, 7.1 megs, 14.1 megs and 21.1 megs. Like I say, so each of those frequencies at each of the power settings, I then measured how much voltage I was getting detected from that 4148 diode, and then being RF being sucked to earth from that little filter there. Now I'm actually going to pause right now, and I want to quickly talk about this before I forget. In the intro video, when I was talking about the ideas for this, I was talking about the Bird 43 watt meter and maybe giving a go of doing a sort of a pseudo loop style. And as was quite rightly pointed out, which is certainly in line with the textbooks, this sized loop, and certainly smaller like the Bird, really is suitable only for VHF and UHF and above. So I decided to, because I'm a pain for punishment, to make it up anyway, just to have a bit of an experiment. So what you're seeing here is essentially the same as that, but subtly different. So we've got the RF coming in, it's going through our 50 ohm coax out the other side. Our sheath is connected to earth, so I'm trying to maintain that 50 ohms through the directional coupler. And then what I've done is I slightly bunched up the outer sheath, and then just used a whoopsie daisy, a sharp little knife, sharp little sort of pointer there, and just sort of made a bit of a hole at each end. And it was actually really easy just to slide in a piece of wire. So there's a piece of wire on this side, and there's a piece of wire on the other side. And then I pulled that sheath back tight again. So what I now have, as you can imagine, is a little loop on the inside between the outer conductor and the inner conductor, in an effort to try and sense that forward and reflected power in a similar manner to that. Now, so we just take the pink wire there, we see exactly the same setup. We've got a 51 ohm resistor here coming through, a 4148, and then that 10 nanofarad capacitor to earth. Flip it around, exactly the same thing on the other side. There's our variable resistor and our 4148 and the 10 nanofarad capacitor. Wasn't really expecting this to work, and funny old thing, it really didn't work. So absolutely no surprises there, but hey, if you don't try, you don't understand, you don't know. So I guess I've just now confirmed the textbooks are correct, so yay. But no, it was good, so it was good to give it a go. I'm not going to throw this away. You know, it could be used for a VHF/UHF SWR meter in the future. So I'm going to put this to the side and we will not see that again. Rightio, so back to this. As I've just said, I went through and I took a series of measurements here. Not a huge amount, but just enough to get a bit of an idea. Because, again, I was expecting this to be a non-linear system. So what I'm going to do now is just going to skip back across to the computer. And hopefully that's visible. Sorry about the refresh rate there. Maybe I should... No, we'll leave that for now. We'll leave that for now. So what I've got here is I've got a the old Google Sheets up, and what I've endeavoured to do is to plot the results. So we can see down here in our input table, frequency 3.7, 7.1, 14.1 and 21. There goes a 100, 1 watt and 10 watts, and there goes those values. So those values are exactly what we just received, say again, measured off the multimeter. And then I've plotted those, which we're seeing there. So the yellow is the 10 watt line, the red line there is the 1 watt line, and then the 100 milliwatt line there is the blue line. So what we can deduce from there straight away, that is at low powers, it's reasonably linear. And as the power gets higher, more logarithmic. Now, interesting enough, on the right hand side I've got the ability to tell Google Sheets, whatever it's called, that's log. So I'm going to click this little button here that says log scale, and you'll see these lines should straighten up. So click. So I've now told it's log, and they are, yeah, for all intents and purposes, reasonably straight. Turn off the log scale, and we're back to a logarithmic graph. So just coming back to here again. So that was to be expected. That's certainly in line with my understanding of the textbooks, that that was going to be a logarithmic detector. Now I'm going to jump in here and say another thing I'm going to do to keep the cost down. In an ideal world, I probably would use an AD8307, certainly from the power point of view, and chances are even for this as well, to provide a linear response, because it's a logarithmic amplifier. But yeah, here in New Zealand, if I was to buy those from the local Element 14, I think it is, that was going to be something like $26 odd. So in keeping with not using these moving needle displays or moving coil displays, I'm going to try, it may not work. If it doesn't, then I'll reconsider it, but for now I'm going to try and continue making this without using an AD8307. So then that sort of raises, well then, what I was thinking is, in fact I might just suck this back down to the lower screen and open this page up. What I was thinking about doing was having an op-amp, so probably an LM358, something nice and simple, but set it up as a logarithmic amplifier. Because straight away we can see that, okay, I've told you before I don't have a script, so I apologise for being a little bit over the place. But we've said, well, I've said that I'm going to input the voltages, so those small voltages need to go into the Arduino. So at the moment, as you can see there, they're pretty small. Now 21 megs at 10 watts, I am getting out 4.46, but all these other voltages here are really small. In an ideal world, if I'm going to feed this into the analog input of an Arduino, then I really want to reduce the old quantization errors in that, is try and take up as much of that 0 to 5 volts as I can. Or I can play around with the VREF, which I'm not going to get into in this video. That'll be later on down track. So as I said in the beginning, step 1 is just, let's see if I can get hold of these DC values. Step 2 is, right, what do I need to condition them? And then step 3 is, okay, once they've been conditioned, let's shove them into the Arduino and do something with them. So coming back to the conditioning side of the house, I know I need to amplify those voltages. So I was thinking about, and I don't know if it's a good idea or not, so I'm just, you know, if people have done this, hey, please sing out. But I haven't done this before, so I'm just sort of just thinking out loud here. Thinking about using an op-amp as a log amp. And it's mentioned quite a few times around the internet. This is an analog circuits. I think it is. Pretty sure it's analog circuits. No, whatever it is. Note saying that with the diode in the feedback circuit, you can then turn this into a logarithm amplifier. So that's what I'm thinking about doing. So I'm thinking about amplifying the voltages with a logarithm amplifier in an attempt to turn them into a straight line and then feed that into the Arduino. The other option is, and again I'm talking out loud here without really thinking too much, the other possibility is to feed them into the Arduino as log values and then do the mathematics inside the Arduino. So I'm not quite sure if that's a good idea or not. I still have to amplify them anyway before putting them in, so why not give this a go? And it's all about learning, so that's what we'll probably do. Rightio, so I'm just trying to think what else I need to cover in this particular video. I think in terms of moving forward, I am going to stick with these. It's easy, simple, shouldn't be hard to replicate. Just, you know, a couple of pieces of coax. I get the impression that the sensitivity of that pickup is really no different from what I'm seeing over here on the commercial antenna tuner with its split needle display. So all things being equal, I think I will stick with this for now and now play around with amplifying those signals and feeding them into an Arduino. At the end of the day, if it turns out to be, like I say, a total disaster, they can always come back, revisit the idea of a toroid or something else. Which just reminds me too, so this is just obviously the SWR side of the house. I still need to do the power. So that's something else to think about. Unless somebody else thinks I can just sort of just utilise the forward power coming off this and just utilise that. Part of me thinks, why not? But again, I haven't really put too much thought to that. Rightio, I'm now starting to repeat myself. So I'm going to say 73s at this point. No, I think I've covered everything I wanted to talk about. No, okay, right, I'll say 73s. I'm going to continue probably playing with this tonight. And like I say, start tuning to some ideas about a log amp. Any comments, please sing out. I will say that, you know, this is not textbook stuff. I'm not inventing this at all, so, you know, this has probably been done before for sure, but, you know, this is just about trying to do something simple, low cost and functional. So I think those are the key tenets there. Like I say, it's not commercial grade stuff, it's not competition grade stuff, and this is about trying to do things in a nice, simple but yet functional way. Okay, cheers all, see you next time.